So hopefully everyone is enjoying the soap bubble. So in this session we're going to be talking about soap bubbles a little bit, but also about Azure Resource Manager, about JSON deployments and doing automated deployments of RDS running on Azure IS. My name is Prerequisites. I work for a company called PowerShell. PowerShell is a system integrator that focuses on the Microsoft platform. And within PowerShell, I'm primarily responsible for anything that's related to end-user computing. So that's RDS, VDI, remote app, etc. I'm also a managing partner at RDS Gurus, which is a consulting company focusing on implementing, benchmarking, troubleshooting specifically of RDS environments running on-premises, on IaaS, or anything else. Also Microsoft MVP, and you might know me from that blog, the Microsoft platform.net. So, about this session. First of all,
what is teamworky?
why don't you explain that, Ruben? So this is the overall agenda of this session, but the idea of this session is that we're going to deployment of RDS running on Azure live during the session. So, as a matter of fact, right after this agenda, we're going to kick off that deployment and make sure it has enough time to run. It takes about 30 minutes to complete. So hopefully, if the Wi-Fi will take with us, at the end of the session, we should be able to see the end result, which is an entirely HA deployment of RDS running on Azure IaaS. So that's including things like load balancing, SQL Server backend, but also things like customization, branding, SSL certificates, publishing remote apps, etc. So while that deployment is running, we'll take a look at these topics here. We'll cover what Azure Resource Manager is, and how, at least I think, it fundamentally changed the way the Azure cloud works. And then we'll dive into the actual JSON template. So we'll grab my JSON template as the example. We'll actually start going through that to make sure that I can explain what happens where. And then for you to take back that information and maybe start using that information to develop your own ARM templates. And in the end, we're going to see some demos and end results, hopefully, of the admin and user experience of that deployment. Good? So let's start by kicking off that deployment. Before we do that, the Wi-Fi is maybe challenging, but we'll see. But this is the resource group in Azure that is currently there. As you can see, there's nothing really deployed there except for two items, which is a storage account and a template image. I'll cover later on why that is exactly, but it is in this resource group that we're going to deploy that entire RDS deployment. So the other prerequisite for this template to work is that AD needs to be in place. So I have a separate resource group here, which holds the domain controller, which is running on IaaS as well. And the reason that the domain controller is a prerequisite is that in most environments that I ran into, AD is already provisioned. So if I'm taking this template to do a proof of concept or test environment or maybe even production environment, the domain controller is already running and that Azure VNet and Subnet is already there. So rather than adding those to my template, which can be done relatively easy, I decided to rather leverage the existing domain controller and networks. All right. So in order to kick off this deployment, we're going to open Visual Studio. And I realize that's not something only done probably on the E2E session, but here is that deployment, which is called RDS on Azure IaaS. And it basically consists of two files. A Azure deploy file, which contains all of our objects we want to deploy, as well as an Azure deploy parameters file that contains the parameters we're going to push with that deployment as well. So we'll cover those later on in detail, but for now, let's kick it off and make sure we have enough time. To do that, I select deploy here, and what the wizard now does is will get the subscriptions and resource groups that are available for my account. It's already logged on with my Azure account there. It should be coming up. So I'm able to select the Azure subscription, the corresponding resource group, and as well as that the JSON template and the JSON parameters file. That is, if we still have Wi-Fi. So while we wait for that, let's talk about stroke bubble. What is a stroke bubble? It's basically this. So two thin layers of dough with a caramel syrup in between. It's really popular in the Netherlands, as it's based in originally from the city of Canada. So you might be wondering, is that the only product that is coming from the Netherlands? No. No. We also have stroke bubble pie. So wonder cake or stroke bubble flurry ice cream or stroke bubble liquor.
Wow.
So anyway.
And those are the only products that come from the Netherlands.
Exactly.
All strip bubble related.
So let's try that again. It's not going to work. It has a video back there, but I'd rather have to, I'd rather want to show it live on stage, probably.
I got really slow about 10 minutes ago, so whoever's doing VR demos, just please stop.
You need another hotspot?
Is that the one?
Try it.
That's Danes.
There's only 2 people on this one. Before I tell everyone to pass.
But why don't you connect to the hotel? Because it's super fast.
It looks like it just sped up.
You need to update the.
Someone just closed their
Dane
call
is
copy.
fast.
Yeah.
No.
Did you have one for the hotel?
All right, get extra hop out.
They should have wire data.
You know what would really help is if you had a remoting protocol.
So we can see who has a cheap internet and who has fast internet. Doesn't care. Jeremy.
Pro. He's over here.
Efficient use of resources. Efficient use of existing resources.
There we go. Thank you so much for helping out. So here is the selection of the description as well as the resource group. Now let's not wait any longer and kick off this deployment. So I hit OK here, and right now my ARM template is being passed to Azure, and we should see the progress of that deployment here. And the first thing it will show up is that it will start to evaluate my template to make sure it is accurate and is correct. Which should be coming up now. Should say something like template is valid. And it will then start, there it is, it will now start to deploy all of my resources into my Azure subscription, into my resource group. So what Visual Studio will now does, or actually PowerShell will now does, it will start to pull the resource group to make sure, to check, to get back the objects that are being created right now. So after this queue 10 seconds, we should be able to get the list of the first objects that are now being created. And there we go. So we're now currently creating network interfaces, load balancers, availability sets, all in Azure. So rather than using this thing here to watch the progress, we'll switch back to the Azure console and to that empty resource group we had before. As you can see, it should now contain a lot more items. It now already has 24 items. So in that few seconds, we already created 3 availability sets to make the entire environment HA. We created a lot of managed disks, load balancers, network adapters, and VMs are now already trying to spin up. So that looks good. So the other thing you can see here in the research group as well is the deployments I have done in the past. A few have been failed and a few have been successful. And there's currently one deployment running now. I open it up. I can see the deployments I have done in the past as well as the current deployment. And if you open that up, you'll get the details of that current deployment. And that is what we'll be watching for the rest of this session. So there's a lot of parameters here. We'll cover those in a minute. But here is the status of all of the objects that are currently being created. So as you can see, here are the availability sets, the network adapters, the load balancers, and the VMs that are now starting to be created. So we'll come back to the screen during the session to make sure that we're up to speed with the deployment. But for now, let's switch back to the slide deck and cover, not the dropouts again, but rather what Azure Resource Manager really is. So Azure Resource Manager, to explain that, let's go back one step and take a look at the Azure portal previously, so the V1 portal or the ASM portal. If you wanted to do management in that portal, you would have to use either the Azure portal itself, so the UI interface, the web browser, or you could do limited automation using PowerShell or the command line interface. That's really the only way to manage those environments. So that all changed with the Azure Resource Manager portal or the V2 portal or the VSO portal or whatever it's called today. It now starts to allow you to organize objects into resource groups. So you can organize them into resource groups and start using role-based access control to allow specific permissions to specific objects. And allow you to do tagging to make sure that when you get the billing at the end of the month, those objects that are from your RDS environment, for example, are all being tagged with the same price. And then there's declarative ARM template, and that's what this is all about. So rather than using the UI portal or using PowerShell, we can now pass a single JSON file towards Azure and have Azure build your entire environment. So how is that different from PowerShell? PowerShell is all about sequential commands. So if I wanted to deploy 10 VMs, those VMs will be deployed one after another. If I would do the same thing with ARM, I could say to Azure, deploy 10 VMs, and Azure will start to deploy 10 VMs at the same time. So theoretically, the time to deploy a single VM will be the same as 10 or 100 VMs. So that's really all about the infrastructure as code for the DevOps story. And then diving into the actual JSON template. So it's a declarative method for defining your objects. You can then use things like TFS or Git or GitHub to start sharing your code with others, other developers or other colleagues. So a JSON file consists of 4 things. There is the parameter section, which allows you to specify and declare parameters that users can pass with the JSON file. And then it's the variable section that allows you to concatenate certain values that are reusing in your JSON template. And the resources section contains the actual resources you want to create, so your load balancers, VMs, network adapters, etc. And then there's the output section, basically allows you to output any values. So for example, if you're creating a public IP address, you might want to output that public IP address for the end user to make sure that that added to his public DNS or whatever. So this is a JSON template, an eye over. Any questions on that before we dive into the actual template? Nope. So again, we're opening up Visual Studio, and this deployment is obviously still running. So So before we take a look at the JSON template, let's take a look at the current status of our deployment here. If we refresh that, you should be able to see that a lot of the VMs are now already running and completed. So these are 2016 VMs running on Azure IaaS now already completed. And it's starting to also domain join these VMs to the existing domain. So we're good on track with that for now. So let's take a look at the JSON template. As I explained before, there are two parts in JSON. There's the actually JSON deploy, which contains all of our objects, and there's the parameters file, which allows you to add values to those parameters to customize that deployment. So the latter will cover first to make sure that we're familiar with all of those parameters. And this is that parameter file. Now, rather than showing you this here in Visual Studio, we'll actually show it in Azure, because this is not most likely the most convenient way to talk to your customer and start adding parameters for his deployment. So what you also can do is add that template to his or your Azure subscription. So I did that before. And here is a imported template, which is called RDS from Azure IaaS. And here you basically see a short description of that template. They added it, and this is the actual template. Now, if I would want to deploy this from the Azure portal itself, that's also possible. I'm not going to do it, but I'm just going to show you where that is to make sure that we got an overview of all the parameters. So these are the parameters for this JSON file, and as you can see, a lot already have default values as well to make it easier for you to fill in this deployment. So what are a few examples of what we can configure here? For example, the names of the availability sets we want to create. You might have a specific naming convention for your customer. You can add those here, or the location for the certificates to use, you can add them here. But also things like session limits. So I can configure here the active, disconnected, and idle session limits I want to add to the deployment. I can add them here. And also things like, for example, the number of servers. So in this case, we're deploying 2 connection broker servers, 2 gateway servers, and 2 session host servers. If I want to have 20, I can just add 20 here, and we'll deploy 20 session host servers, add them to the domain, add them to the collection, etc. And also I can specify the OU location for the existing AD and where to place these objects. These are just a couple of examples of the parameters. It's about 70-something parameters right now. I won't cover them all. But these allow you to customize this deployment before running it into a environment. Any questions on that so far? Good.
Yeah, so if you deploy like this with those 2 servers, you want to go to 20, do you have to tear down and start over, or does this allow you to make that change on the fly?
It does allow you to make that change on the fly. Yeah. And also if you're, that's one of the powers of ARM as well. If you want to add a certain other VM like a file server or you want to store WT
More like
profiles.
this is the policy of what I want right now.
I'm sorry?
More like saying this is the policy of what I want right now as opposed to a scripting thing.
Yes. Yeah. Okay. So these are the parameters for this deployment file. Now let's take a look at the actual JSON file to make sure that we are familiar with what's in there. So on the left-hand side, you'll see those 4 items again. So the parameters, the variables, the resources, and the outputs. So the parameters section here, this is really the declaration of all those parameters again, to make sure that we can specify the type of that variable, or maybe the description or the default value. So again, this is the same list of variables, but then declared with a type and with optionally a default value. And then there's the variables section that allows you to configure some static values yourself that you're using across your JSON template. And for example, I can specify the names of the connection broker and gateway load balancers, or I can specify the ports that the gateway and the session host servers use. And I'll reuse these variables across the rest of the JSON template. This is also used, I'll get some more room here. This is also used to concatenate certain values, like for example, if I want to specify a network ID, I could use functions within JSONs, like for example, concatenate, to concatenate a variable with a static string, the parameter, etc. So that's all possible within JSON as well, including things like add or subtract functions. And then we'll get into the actual resources. So for this deployment, we're deploying 14 resources, and this is that list. So the first item here is a public IP address. So for this RDS environment, we want to make it accessible from the internet. So the public IP address is needed for the RD gateway and RD web access role, and this one is in fact connected to the load balancer that we're creating later on. So as you can see, it's of type public IP address here. I can add it, give it a name that's coming from a variable. And in this case, it's a static IP address because I want to make sure that the outside IP address doesn't change over time. And then we have 3 availability sets. And those availability sets that allow you to make sure that VMs that are running in a single availability set are HA, so that are highly available, and that only one of them is down during maintenance between updates. So for each of the components, we're creating a separate availability set to make sure that the gateway servers, connection broker servers, and gateway servers, and session host servers are all running in a separate availability set. So since that deployment is already on its way, we should be able to take a look at what that looks like in the Azure portal. So we'll switch back to the resource group we had before. And let's take a look at the first 2 resources that we just discussed, public IP addresses and the availability sets. So here is that public IP address that's already created and available, and the static IP address has been reserved that we'll later on add to our DNS to make sure we can test this environment. And also 3 availability sets are available, and if you open those up, they will probably already contain the VM. So in this case, the availability set for the connection broker and the 2 VMs that are running the connection broker role are already added to this availability set. So the next resource we're creating here is a load balancer. This is a load balancer for the RD connection broker role. So this load balancer is the initial connections that are coming in, end users are using to connect to the environment. It is an internal load balancer, it's not published on the outside, of course. So for this object, it is of type load balancers. You can declare, you can give it a name, and what you can do is add an IP address here. In this case, I'm adding a private IP address with a internal prefix that's coming from the parameters section followed by a static number. And then you can add load balancing rules. So in this case, I'm only load balancing for 5889, the RDP port, to make sure that we're load balancing that initial incoming connection. And for that load balancer, for this one is really it. So let's take a look at what that looks like in the Azure portal. Here you have that RD connection broker load balancing already created. If we open it up, you'll see that it already contains a backend address pool with 2 VMs in it. Those are the connection broker servers, the health port 3389, as well as the load balancing rule that load balances 3389 traffic across these 2 VMs. The second load balancer is the one that's actually published on the outside. So this is connected to the public IP address, and this is for the first time in this JSON template, you'll see a depends on section. And this allows you to specify that this object is dependent on another object. So to make sure that ARM knows that it needs to create a public IP address first in order to create this load balancer. And in this case, we also have a backend address pool and a couple of more ports because we're also load balancing HTTPS, HTTP, and UDP 5391. So let's also take a look at that load balancer in our portal. That's the gateway load balancer. And as you can see, 2 VMs have been added to that as well, gateway load balancers, and 3 load balancing rules are available. If you open those up, load balancing rules, we see the rules that are added for HTTPS, UDP, and TCP port 80. I'm adding port 80 as well to make sure that I'm able to do a redirect of HTTP traffic to HTTPS in IIS. Let's take a look at then the network interfaces. So obviously the VMs that we're creating, they all need a network adapter to make sure it's able to run and they're connectable. So as you can see, it seems like we're only creating 3 network interfaces here. Rather, we're running these resources multiple times. So we're using the what's called the copy command in that resource group, and allows me to specify I do not want to create this object once, but I want to create it multiple times, and it's configurable using the number of instances for RD gateway. So that is where the parameter is used. If I would add 10 for this parameter, it will create 10 network adapters used for my 10 VMs. And also you'll see another depends on section here, and that is the VM is dependent on the creation, or this network adapter is dependent on the creation of the load balancer. So for all 3 types of VMs, we create those network adapters for RD gateway, RD connection board, and RD session host here. So if we switch back to the portal, we here see the 6 network adapters that have been created for those 6 VMs already. So then we come into the actual virtual machines. So now that we have created availability sets, network adapters, and load balancers, these are all required and dependent on the actual virtual machines. As you can see, we're creating virtual machines for the RD gateway, RD session host, and RD connection broker role. So in order to create a VM, I use obviously the types of virtual machines, and I'm able to specify all of the properties for this VM, like the depends on section, the hardware profile, the availability set that we'll connect to. And again, we're using that same copy command here to create multiple VMs for this role. Notice also that I'm using the name here, so the name of this VM will be concatenated based on the prefix, which is a parameter, followed by a 0, followed by the copy index number 1. So if I would create 10 VMs, the first VM would be named RDSH-0-1, and the second one would be -0-2, etc. And a few lines down, we can also specify the OS disk, the image we want to use. In this case, I'm using 2016 as today's image, and option also add data disks to this environment as well. So that creates a VM 2016 running on Azure IaaS using a managed disk. And let's take a look at those VMs. So in the meantime, those 6 VMs are now ready, and they're running, probably also ready domain join later. But the second thing we can add to those VMs is extensions, because if you're just deploying a VM, it will just be 2016 running with nothing on it. So we want to join that VM to the domain first. So we use the domain join extension for that. This is something that is already available in JSON, so I can specify the type, which is an extension. Then I can specify the actual type, which is JSON AD domain join extension. What it allows me to do is configure these settings to make sure that that VM is added to the domain inside the OU and using the service account I want to use. If we would switch back to the domain controller here, and I refresh this, you see that the connection broker servers are now added to this domain, as well as 2 gateway servers and 2 session host servers. Don't look at the times. These are all web Europe times, but they have been added, as you can see, in this time zone. So the second extension we want to run on this VM is we want to add anti-malware and antivirus using Defender. So that is also automatically configured here. In that case, I'm using the, again, the extension. In this case, I'm using the IS anti-malware extension, which is also available out of the box for JSON. So what this extension does is it enables Defender, but also adds exclusions for paths or processes you might want to exclude from your VM for your specific workload. And then also is added a BG info. So all VMs will automatically be added with BG info on the screen to make sure that you can check the information of that VM as well. And then the last extension, which is the most important one for this environment at least, is the PowerShell extension. What PowerShell extension allows you to do is allow you to kick off a PowerShell script after the VM has been deployed and domain joined to do the actual RDS deployment. So what the PowerShell extension will do is will download a PS1 file that you specify in that extension. So here I literally say PowerShell.exe unrestricted, and I pass the PowerShell file in order to download that and to run that on the VM. So these types of VMs, they also have different PowerShell extensions to make sure that we're also configuring the RD gateway role and also configuring session host roles. But the biggest one in here is the PowerShell extension for the connection broker. That is where the entire RDS deployment will be created. So as you can see, this also has a huge depends on section because this thing is dependent on all of the VMs that have to be domain joined and ready and available for this to run. So we'll take a look at that PowerShell script. Before we do that, let's take a look at how far we are with the actual deployment. It's still deploying, which is as expected. Oh, and don't pay attention to the duration because that is not very accurate. Here you can see that this is now, for most of it, already completed. So all of the VMs are running. They have all been joined to the domain. BG info has been installed. Defender has been installed in all these VMs. And this is the RDS customization PowerShell extension that is now currently running. So it's now creating the actual RDS deployment on top of these VMs. So it's good timing because that is the PowerShell script I want to show you here. It's called configure RDS deployment. So what does this do? It starts to install the SQL Server native client, which is needed for the ID connection broker role to make it a chain, to make the connection towards the central SQL Server that stores the connection broker data. And it then continues to import the remote desktop module. It creates the actual RDS deployment using PowerShell, and then adds the RD connection broker service as license service to this deployment. And then adds the web access service to this deployment, adds the gateway service to deployment, and it creates the high availability for the connection broker role, and adds the additional RD connection broker service to this deployment as well. It then continues to create the session collection and deployment, and also configures a few example remote apps, Word, Excel, and Paint.net. It configures the timeout sessions that are added to this JSON template. It configures SSL for all of the roles, so RD connection broker, gateway redirector, these are all being configured using SSL. Licensing is configured to make sure that we're running in the correct mode, user mode, computer mode. The workspace name is branded to the name that's passed as a parameter, and then it finishes. So this script does the entire RDS deployment after all of the VMs are provisioned. And then there's a few other PowerShell scripts that do additional things. I'll show you this one as well. This is used to customize the RD web access and RD gateway role. So what it'll actually do is copy a custom logo from a custom location, do some branding. It will change the password option in case you want to use password change in RD web access. It automatically redirects any HTTP traffic to HTTPS-RD web. In this case, it hides the desktop tabs in the web access page. It changes the RD web access remote app and desktop title. And then it starts to remove the default RD cap and RD wrap rules. If you're familiar with that, the RD gateway comes with a few default rules that allow any domain user to connect to any domain computer, which is, from a security standpoint, not the best option. So I remove those default rules and then I add specific RD cap and RD wrap rules to make sure that a specific group has access to specific domain computers. And then I create a managed group to add also all those VMs to make them available. So that is what this script does. Any questions so far?
Question on the JSON stuff.
Sure.
Is there, if you have something in the Azure GUI, can you create the template from something, an object in the GUI, so it'll create the right parameters for you? Is there any way of going that direction?
That's what we mean.
In terms of knowing the right parameters to create the JSON template, can the Azure GUI do that for you for a particular object, like a load balancer, for example?
Well, the template that you create in Visual Studio, at that point you're able to declare all the parameters that you want for that template.
Yeah, but how do we know what they are? What they're supposed to be? Where do we get the structure of that particular template for that object?
Yeah, you give a way to add a description for each of those parameters and also add a default value to make sure that you're directing the user who's actually deploying that template into the right direction.
Maybe the question is, if you create it manually in the portal, is there a way to extract the information backwards so that can happen? So that was maybe the question. You do it once manually and then you want to have it as a scripted.
Yes. Yes, you can do that.
Was that what you
That's
wanted?
exactly what.
Thank you. Go on.
I was wondering that as well.
Thank you for that translation. The option is called automation script. So in any resource group, you are able to open that automation script, and that will provide you with the actual JSON template, including the parameters that were used to make that deployment. So you can then copy that back into Visual Studio, start re-adding it, etc. And you can do this for any deployment that is, or any resource group that is done. So also for resource group where you manually added things in the portal and you wanted to see the JSON code behind that, this is the way to do it. Yep.
Is there also like a reference document?
There is a JSON reference document that has all the parameters, functions, and the layout, the variables, etc. If you look for JSON reference guides, I think that's how that. So let's take a look at the deployment. I'm glad actually this one crashed because this is something I wanted to show you as well. This is Visual Studio losing the connection to Azure and a timeout occurs. So if you're doing JSON deployments using Visual Studio, in 50% of the time you'll end up with these errors. This error doesn't mean that the actual deployment stopped. It only means that the polling action from Visual Studio ended. So if we actually switch back to the Azure portal and open up the resource group, you should be able to see that the deployment is still running or already complete. Yep, it's still running. So don't pay attention to these errors. It's probably fixed in the next Visual Studio. So let's take a look at the current status here. As you can see, the RDS customization is now already complete, and that is the PowerShell command we just saw, the entire list that created the entire RDS deployment. So it's now working on customizing RD web access and RD gateway, so those logos, those RD cap and RD wrap rules, and also adding any existing or additional session host servers to the existing deployment. So this should actually finish relatively quick. So let's take a look at the last part of the deployment here that creates the SQL Server. So because I'm using an HA mode for the RD connection broker, I'm leveraging Azure SQL as the database to store those connection broker data. So in this case, I'm actually creating a SQL Server in Azure. So this is not a VM running the Azure SQL or running the SQL role, but rather the Azure SQL platform as a service to run that database. And then I create a database on top of that for the RD connection broker role. So during the RDS deployment, it will point to this existing database and start leveraging that database to store connection data. And finally, we have the output section that in this case outputs the actual HTTPS RD web access URL that's concatenated from the parameter that I chose, including the dash RD web, obviously. I'm also outputting the public IP address that's created as part of this deployment to then later add this to DNS to make sure that we are able to test this environment. So let's see that this is already complete. And it is. So just for, so let's take a look at, it took 30 minutes. So 31 minutes to complete this entire RDS deployment, HA running on Azure ADS. 5 minutes?
5, pushing it.
So let's quickly take a look at the end result here. So this is that domain controller that is sort of used as a management server as well. If I open up the server manager console here, you can see that I already added all of the servers that are part of this deployment. These are all coming online now. And I should be able to open the remote desktop services tab in Server Manager. And if it refreshes, it's still as slow as in the install version. I don't know why. You can see the entire RDS deployment, so all the components have been included, been added, including RD connection broker HA. All of the roles are added to the VMs here. And if we open up the collections area, we can see that the deployment is HA, that's running on Azure SQL for that. That the gateway is configured and used. That certificates have been deployed and successfully running, so they're all trusted and all okay. Licensing has been configured to use per user for these machines that are running the licensing role. And if we dive into the actual collection, we can see that a remote app collection has been created that's giving permissions to one of the parameters, which was the AD group. That 4 remote apps have been published for this environment as well. So let's now take a look real quick at the end user experience. So since we now have the public IP, let's check out what that public IP became. And I'll copy that IP and I'll add that for now to my local host file. Obviously would add it in DNS in any other environment. And that allowed me to browse to the RD web access page and get automatically redirected to HTTPS /RD web. If we're lucky. Save it.
Which one?
There we go. So here's RD web access running. As you can see, it has been branded with a familiar looking RD Gurus logo, workspace name, and a corporate application's name. As you can see, certificates have been deployed, because here is the RDS Guru's wildcard certificate in place. I'm actually able to log on with one of the test users that is inside the user group that has access to this environment. And here are 4 remote apps that are running. And I should be able to open one up, make a connection to the RD gateway, get a full single sign-on experience towards the actual remote app. Now, Pay.net is not maybe the best option to choose because it takes a little while to load, but it should work.
Freak, is that available on GitHub?
Not yet, but we'll get there yet.
That means never.
Definitely.
Well, full in that regards, full disclosure, I'm also working with the RDS product team on helping them get similar objects and similar JSON templates as well out there. Yes.
Just one more question. When you build more complex JSONs, do you find any value in the visualizer at all? In that
I don't really use it, no.
Okay.
No.
So what was that tool you mentioned, mate?
There's a tool that is created called a visualizer, where you can take your JSON files and put them in and make them visual, so you can actually see the flow, a workflow, if you will.
Okay.
Yes.
So here is Pay.net running as a remote app with touch enabled, things like that. So this is the end result. So let's do a really quick recap of what has been created here. So these are the objects that have been created in Azure. So 6 managed disks, 6 network adapters, VMs, availability sets, Azure SQL database, public IP address, and 2 load balancers. On top of that, this is all that's being created in RDS. So all of the VMs are now joined to the domain. Antivirus, anti-malware was configured, PG Inkle was added, and a full H8 RDS deployment has been created, including 2 load balancers, gateway servers, session host servers. SSL certificates have been configured. The collection has been created, a few remote apps have been published, and we've done some branding and customization for RD Web Access and RD Cap, and session timeouts have been configured. All of that in 31 minutes. So, available. If you have any questions, just let me know. I'll be here the rest of the day and tomorrow as well. Thank you.
Thank you.
Thank you.